Okay, so now we're going to find the total electric potential at the center of the triangle. And remember, electric potential is just adding numbers. I don't have to do anything like I did in the last chapter where I have to find vector magnitudes and components. So all I need to do is I need to find the size of the potential at that black dot in the center of the triangle from all three of the charges. So let's call these charge 1, charge 2, and charge 3. And I'm going to find V1, V2, and V3, and then add them together. All right, so V1 is KQ1 over R1. V2 is KQ2 over R2. V3 is KQ3 over R3. And we know K and Q. K is 9 times 10 to the 9. Q1, that's the one in this bottom corner on the left, so it's -1 nanocoulombs. And then we have to divide by R. So let's come back. Let's put in all our numbers for charges. Q2 is +2 nanocoulombs. Q3 is another -1 nanocoulomb. Okay, so what's the distance? Well, the distance for R1 is the distance from charge 1 to the center. Distance for R2 is from charge 2 to the center. Distance for R3 is from charge 3 to the center. And since it's an equilateral triangle, R1, R2, and R3 are all the same as each other. All right, so we're going to have to do some trigonometry to figure out what is the distance. All right, so let me draw, I'll just draw that bottom triangle. Okay, so I know I've got 3 centimeters on the bottom. And then I've got R1 and R3, and those are the same as each other. So I'm just going to say R. And what else do I know? Well, it's an equilateral triangle. So each of the corners in the equilateral triangle are 60 degrees. And that triangle that I just drew bisects it. So the base angles in this triangle are 30 degrees. Okay, so I want to find this side R. I know that this length is 3 centimeters. So let me just take half of that. All right, so I'm going to make a right angle triangle out of it. And the nice thing about a right angle triangle is now we want to find the hypotenuse. We know this angle is 30 degrees. And we know that the bottom side is half of 3 centimeters. So it's 1.5 centimeters. Okay, so the 1.5 centimeters, that's adjacent. So it's the cosine of 30. All right, so I know that 1.5 over R is equal to cos 30. So R is equal to 1.5 over cosine of 30. So I get 1.73 centimeters. And that's my distance. Same for R1, R2, and R3. And remember, the last thing we have to do is put that into meters. Okay, so we're going to divide all of these by 1.73 times 10 to the -2. And then put the numbers into our calculator. So if I put them into the calculator, I get -520.2 volts. Let me separate those out. Plus 1040.5 volts and -520.2 volts. And if I do V1 plus V2 plus V3, I get a total voltage of 0 volts. Okay, so the net voltage is 0. And it's important that you put in the signs of the charges when you do this in order to get it to work. You notice if you look at this that it actually adds up to like 0.1. That's because of rounding errors. I should have kept some more significant figures. This should have been like 0.25 and 0.25. All right, the next problem, problem 4, uses the same triangle. I'm asked how much work was needed to assemble the triangle. Okay, so how do we do that? Well, remember the rules for doing work. Work is equal to Q times delta V. We bring them in one at a time. So we start off with, let's start off with my charge 1. So I'm going to start off with charge 1, which is minus 1 nanocoulombs. I'm going to put it in place. And the rule is that work 1 is 0 because the first charge is free. All right, now I'm going to bring in charge 2. So let's do this in another color. So do some color coding. Charge 2 comes in, it's up at the top of the triangle. So now charge 2, I'm going to move it from a distance of infinity. I'm going to move it to where it's 3 centimeters or 0.03 meters away from charge 1. And so what's the work for charge 2? Work for charge 2 is the charge that I'm moving, so Q2 times the voltage that it feels due to, in this case, the only other charge there is charge 1. Okay, so Q2 is 2 times 10 to the minus 9 coulombs. And again, it's important that you put the sign right. Okay, so it's Q2. And what's delta V1? Delta V1 is V final minus V initial. And V initial is always 0 because we start them off infinitely far away. All right, so it's going to be just K Q1 over R. Okay, so it's going to be 9 times 10 to the 9 times Q1, which is minus 1. And again, remember, put the sign in there. Divided by the distance that it is at the end, which is 0.03 meters. And so I get a total work that's negative 6.0 times 10 to the minus 7 joules. Okay. All right, so now I'm going to bring in charge 3. So charge 3, let's go with blue. So here's my charge 3. I'm going to put it in this bottom corner. And now charge 3 is going to be 3 centimeters from charge 1 and 3 centimeters from charge 2. So let me scroll this up a little bit. So the work for charge 3, again, it's the charge that I move, charge 3, times basically the potential that it feels when it's in position. So it's going to feel a potential due to all the charges that are already there. So it's going to feel a potential from charge 1 plus a potential from charge 2. Okay, so that's Q3 times K Q1 over R1 plus K Q2 over R2. All right, so I'm going to put in K, Q, and the R's. In this case, are equal to each other. In most cases, they won't be. It's just because this is an equilateral triangle. And now I'm just going to plug in my number. So I've got Q3, charge I'm moving, minus 1 times 10 to the minus 9. Then I've got 9 times 10 to the 9. Q1 is minus 1 times 10 to the minus 9. And again, it's 3 centimeters, 0.03 meters. Okay, so I get, if I go ahead, let me go ahead and just do these calculations. All right, so this comes out to be V1 is minus 300 volts. V2 is plus 600 volts. All right, so I get minus 3.0 times 10 to the minus 7 joules. All right, so how do I get my total work? Total work is equal to the sum of all the works. So work 1 plus work 2 plus work 3. So I've got 0 minus 6 times 10 to the minus 7 minus 3 times 10 to the minus 7. And so I get a total of minus 9 times 10 to the minus 7 joules. And so you do this no matter what the shape is. You follow the same steps. First, work. First charge you move in, the work is free. Second charge you move in, you fight against the voltage from the first charge. Third charge you move in, you fight against the voltage from charge 1 and charge 2. And you just keep doing that, adding one term of voltage each time.